Hey, welcome to the 30-day GeoAI challenge. For every day up to day 10, we are going to master on every topic related to the geospatial data analysis and the AI to make the foundation of GeoAI. Today we are going to masters on Geopandas on this day. Without further delay, let's get started. Okay, go to your favorite browser and search for the anaconda.com the docs getting started /miniconda/install. Hit enter and you are direct into this page. Go to the window installation and go to the command prompt and copy the command and search for the cmd on the Windows search bar and hit enter. Okay, and the miniconda.exe file start to download and wait till it get downloaded. Yes. Okay, yeah, it is completely downloaded. Okay, close it and search for miniconda. Yes. Okay, miniconda. Yeah. Go to the open file location here and right click on it and go to the run as administrator and click yes, and then next, agree all users, and then next. Okay, next, and check all these all two buttons, both of them. Okay, register miniconda as a system path 3.12 and clear the package catch after completion. And okay, hit enter and yeah, it's completed. Hit enter and uncheck both of them and click over the finish. Yeah, we have successfully installed the miniconda 3 in our machine computer and search for anaconda prompt. Right click on it and click on the run as administrator. Yeah, and here we need a separate environment to work on the any of the specific tasks. So we are going to create a virtual environment GeoAI by running conda create -n GeoAI. Yeah, okay, hit yes y and then it automatically downloaded, and we are activating the GeoAI environment by writing conda activate GeoAI. You can see GeoAI at the left button here. We checking all those environments available in my computer, and those base and the GeoAI is recently created, and the weather and the yellow view 11 is my old environments. So you have only the base and the GeoAI. So we are going to install all those packages, and here it's time we are going to install the Jupyter notebook by running conda install Jupyter notebook, and it automatically start to download. Yes, it get downloaded, and we are going to download other packages too. Here at this time we are going to install Geopandas. So by running conda install Geopandas. Similarly, it also downloaded by entering yes. Okay, it's executing and done. Okay, similarly we are going to install matplotlib, pandas and other features. At this time we are checking whether the numpy get installed or not by command install numpy. It says that all requested package already installed. You no need to further installation of the numpy. Then again we are checking for matplotlib by running command install matplotlib. Yeah, but it has not downloaded yet. Okay, yes, click over. Yeah, it downloaded. Yeah, we done it. And we are running our Google Colab environment into the local machine. I think you may know that Google provide us certain RAMs and the disks, but I think it needs a continuous internet connection, and the RAM and disk is limited. So if our computer is much powerful than the available spaces in the computer, we can use the Google Colab. So here we are going to using the Google Colab. Here using the CD path, we are mentioning the directory, and we renamed it to the day 1. Yeah, and you can see in the you can, yes, day 1 Geopandas. In the connection there is a small bar, you can see, and here you go to the instructions and copy those Jupyter runtime instructions. Okay, copy it and open the notepad and paste over it. Yes, and clear all those spaces before those double dash, and keep all those lines all those codes on the single lines, and do not clear the spaces before. Yeah, and copy this and paste the link on the command cmd prompt, and you get the local server here. Yes, and go to the local connection and paste the over here. Okay, and it's connecting. Yeah, we are ready to go, and we check the whether the model are perfectly downloaded or not by importing them. Importing Geopandas GPD and importing pandas is PD. Yeah, the main thing is the main advantage of the using the Google Colab is it provides us too much AI platforms, so that it is very easy for us to do a code here. And we are mentioning here we are going to use the I am inside the day first of the 60-day GeoAI challenge, and we are going to going to visualize the world administrative boundary. The data is in description, so you can download all those data from the description and provide the improper path by mentioning the R dash and all the path. Yeah, hit shift enter, so that GDF is equal to gpd.read file, geopandas.read file. Yes, read file and the URL. And if you get the suggestion, hit tab, you get the gdf.head to get the first 5 data of the GDF. Okay, I'm sorry, it's GDF. Yes, geodata frame.head. Yeah, we can see all those headings of all those attribute features of the geospatial data, 5 features of the geospatial data, and the country name is inside the name, and we are going to visualize the plot, visualize the data. Those special data, location data, that. We are going to modify figure axis is equal to plt.subplots, and we have figure mentioning the figure size. The default figure size is here it is, and we have to mentioning the plot and light blue, and the color is color of the fill color and edge color, and okay, and we are going to run the code. Yeah, this is the 15,15 figure size plot. Yeah, and we are going to give the title of this plot is plt.title. Yeah, and it's a world boundaries. World boundary, and it's x label and y label by plt x label, and x label is a longitude obviously, and in the y label it's a latitude. Okay, I think I am missing dash and the parentheses. Okay, yeah, it's run perfectly at this time. I think the tutorial is too much fast because we have to cover everything on this tutorial. So please pause the video, and you can run with me. Yeah. So we are going to create the new fields of the data by, okay, we can calculate the centroid of the each figure, and mentioning the centroid in the and keeping those centroid value inside the centroid field of by giving this. If we plot the if we visualize the GDF centroid, we can see the centroid of the each of the country. Isn't it cool? Okay, and GDF dot area, if you want to calculate the area, you can simply create by GDF dot area, and if we mentioning and we are keeping all those area inside the area field by GDF area is equal to GDF dot area. Yes. Because it's so warning because the projection system is in the geographic coordinate system, so we have to convert it into the projection coordinate system to get the best or the accurate area. So after some time in this video we are going to fix this slide, and if we visualize the head, we get the centroid and area as well. Okay, and at this time we are going to plot this data by keeping the area as a field. Area is a field. Okay, my GDF dot plot brushes area and legend is equal to true to give the legends. Yeah, and you can see all those suggestions here. Yeah, okay, let's run the code. Okay, key error area, I think everything is okay, but I think okay, let me check again. It's the key area small a, but I think before here we have a capital A in the area field. So okay, let's run again. Such a cool picture. We get the plot of the country by the area according to their area. And if we run the explore button, the Geopandas library automatically overlap our images with the OSM base maps. It is the perfect tool to visualize our data as well as the attribute at once. Okay. Okay, let's check the coordinate reference system by gdf.crs. Here we can see that it's the geographic coordinate system. EPSG code is 4326, and all these axes are the geodetic latitude and the geodetic longitude is in the degree. And if you need scale of the data, what to do? Yeah, we can also keep the scale on the each plot. Yeah, so we need one other model. Name is okay, I think it's yeah, matplotlib.scale bar. Yeah, it's the scale bar. If we run, yeah, but if we are going to run the installation tool using the pip, we have to claim those such exclamation mark or something like that, and it's get automatically it's get downloaded here skill bar, and we can import the skill bar from matplotlib underscore skill bar dot skill bar, import skill bar, and access, and at the same as before, we are going to plot our map by keeping the skill bar, and gdf.plot area, and okay, and legend is true, obviously, by it's a small legend, it's equal to true, and okay, and this time we are going to access dot okay future okay aid artist yeah, aid artist comma inside skill bar 1. You can see the suggestion skill bar 1. This is the cool feature of the collab. Yeah, but I think at this time I get the same error, and by doing the same mistake, and I can fix the error by keeping the area. Yeah, you can see it's the 75 meters. Yeah, okay, what to do, or if we need only a subset of the data, I think if we need only the figure of United States, only the zip file of India, only the zip file of Nepal, or only the zip file of Uganda, or something like that, what you need, and just okay, subset of, if we are let's visualize the gdf.head, and if I'm going to take the zip file of the Uganda only, and it is the Uganda file is in the first, and it has the SN value 0, and its name is UGAND Uganda, and it's a capital U here, and okay, Uganda is equal to GDF bracket GDF, again in the same bracket we have to mention the column name, and if in the geodata frame column name is there any name that is similar to the Uganda, it is checking. If it is checking, it automatically mention those only the Uganda portion into assign the Uganda portion into the Uganda variables. And let's plot. It's a plot. Similarly, if we are going to check, we are going to making the map of the India by keeping all those features as the same. Yes, we can plot. What if we have to explore the feature? If we want to explore the India in the world map, we can simply doing it by India.explore. Here you can see the India above the OSM layer. Okay, let's visualize for the Nepal by keeping all those similar features, but then we have to change the name to India to Nepal, and let's explore the Nepal by Nepal.explore. Hit enter. You can see the zip file overlapping over the OSM layers, and it also shows the attribute table at the same time. Okay, let's go to we are going to merge the table value to the attribute value. If we need a further analysis in the data set, I think all those data are in the all those data are in different files, and it may not be embedded as data, so we have to embed the data. So at this time I am going to use the population data of the world, and we are going to assign the population to the each and every country. And this is called the table linking of the table in the sector of the GIS. And yeah, if you want to, what to do if we, how can we do in GIS, what to do if we want to import the data from the table. It's import pandas as PD. Yes, it's a table. It's equal to, yeah, there is a cool feature, pandas read excel. If you want to read the .excel file, xls file, that is there is the feature read excel. If you have at this time, if you have a CSV file, then we mention the read CSV at the time. Yeah, go to the, yeah, mention, yeah, I'm mentioning the path, giving its path. It's inside the 60 days GUI challenge. It was originally created for the 60 days, but I merged here in the 30 days. You can see in the properties, it is the XLSS file, and give its name to the population data .xlsx. Yeah, okay, hit enter. Okay, it said that the OpenPyXL is missing, so you have to manually install the OpenPyXL to read the Excel data set. So by running the pip install OpenPyXL, do not forget to keep the Excel those something mark, this mark. I forgot the name of the marks. If you know the marks, please hit comment. And okay, pip install OpenPyXL. It's successfully installed. Let's run again. Yeah, successfully this time. And if we let's visualize the table head, table 5 data, first 5 data head. Yeah, it enter. You can see the SN value, name, and the population. It's the name exactly in the same order of the same name that you have seen in the geodata frame. Yeah, okay, yeah, if you compare those data, it's the name, and the name column is same. We can merge the data. Yeah, we can merge the data by keeping the name is the, I think it's a in the database. If you run the database, that is you run the foreign key, like it's same like a foreign key. If you say both the data column is, that is, yeah, the column is common. Yeah, name column is common. So you understand that I'll just mention you. Yeah, okay. GDF is equal to GDF.merge. GDF is equal to okay, GDF.merge. Yeah, the suggestion portion of the collab is too much perfect for us. Yeah, if we, yeah, let's visualize the total head. Yeah, total head this time. Yeah, it's cool. You can see the population here. And okay, let's plot the world data by keeping the population. Yeah, okay, we are going to plot according to the population, and we are giving the color to each country based on its populations. And okay, keep the legend true to see the population of each country. But I think it provide the legend for every country, so we have to remove those legends and legends at this time. I think it may work. Let's try this. And by, yeah, okay, I'm going to remove legends and the CMap and keep the population only. Okay, let's plot here. Okay, you can see the see the plot of the world according to its population, but I think the population of the large country is more high, so it dominates the small country. Yeah. Okay, let's start the geoprocessing using Geopandas or Python Geopandas. um, and I think um, it's the advanced analysis in the Geopandas in the Python field. Yeah, we can do clipping, buffering. I think you mean the clipping and the buffering, and we have to make sure the data is in same coordinate system or not. If they are in the different coordinate system, and they may create the problem. Yeah, so we have to keep all those data in the same geographic coordinate system. That is called the data integration in the field of GIS. I think. Yeah. First we are going to for this time we are going to load two different data of the same location and perform the geoprocessing using the Geopandas. Yeah. Okay. I have two data sets, and one is boundary data set and the one is row data set, and the both of them have the same locations, and so theoretically they must have to plot on the same times. Okay, let's read the boundary file at first. By okay, boundary is equal to gp.read file r dash, and we have to mention the path of we have to mention the path of this file. So it's inside the geo of day first. Yes, it's inside the day first. Go to the spatial vector ladder and go to the California, and it's inside the neon Astro site. I don't know the site of the site, but this is the data from this site. I get this data from the different online sector, so you may check this data in the online. I will mention the credit to this data also. So yeah, we have to mention the zip file _crop.ssp. Yeah, just copy it and paste it inside. Yes, crop.ssp. Yeah, it's boundary data. Get read. Let's plot the data. Yes. Yeah, it's plotted here. It's in the projection system. You can see that 255,000, and then you can see 4.108 into 10 to the power 6. Is in the 1 is 6 means 10 to the power 6. That is mentioning in the top left corner of this plot. Let's again plot the import raw data, or let's read the raw data of same locations, because I know that it's the same location data. Yeah, it's a Madeira road, so Madeira road is equal to gpd dot read file bracket, we mention the path rs. Okay, so again go to this link and copy the just one step back, and on its back is the Madeira country road, and copy the path from those above here. Copy the path and paste it inside rs. Yes, and mention the exact name of the exact name of the road. Yeah, it's a TL 2013 06039 roads.ssp. Copy the path. Yeah, and paste it here. Okay, it's yeah. Again, let's plot the data. Madeira road dot plot. Okay, that's perfect here. Let's plot together. Okay, both of the data have, yeah, at this time you can see the projection is in the different. I think those scale the so is different. So if we plot together the data, you can pause this and see if we you can plot together the data, and I think none of the data get displayed here, and it's due to the problem that okay, what's the problem? Okay, what's the problem? Can you figure out? Okay, let's I think it's due to the projection system, because the axis plot above is different low. So let's check the projection system of both of the files. Okay, projection system. There are the different projection system according to our requirements, but if we are going to making analysis using both of the data at once, so we have to make sure that both of the data are in same projection system. So if both of the data are in the different projection system, we have to keep this in same. Okay, let's visualize the Madeira road.crs projection system. It's the APSG 4269 projection. Yeah, and if we check the CRS of the coordinate reference system of the boundary, then we can see the 32611 projection system. It's a projected coordinate system. Boundary is in the projected coordinate system, and the road is in the geographic coordinate system. So we have to reproject the raster, reproject on reproject one vector. Yeah, we can change one vector to another, change the projection system of one vector data to the another vector data. Okay, do you know the how to project? Do you know the projection? If you know it, please please do comment. and if you know why we need the same projection system to plot together to make the analysis together, you need to you can comment down below. Okay, and if I'm doing some mistakes, you can also let me know in the comment. I'll figure out, and I'll definitely solve in the next video. Okay, boundary WGS. Okay, boundary WGS 84 equal to boundary dot, yeah, at this time okay, to CRS and CRS APSC 4326. We have to write such like init at first, and EPSC 4326 in also in the same inverted comma. Okay, 432 is a 4326. So we are not going to keep the boundary in the WS84 because the no of the data are in the WS projection system. So I am going to keep the boundaries projection system, which is resembles with the road coordinate system. It's in the NAD 83. Yeah, and by keeping the 4 APSG value 4269, okay, but internal projection error, it shows that, because okay, I think everything is okay, but sometimes we have to modify the code. APSG, okay. I think it works. The same error, projection error. Yeah, one cool feature of the collab is we can, yeah, collab automatically get fix all those data. I didn't have to think anymore. So click on the explain error, and based on its hypothesis, it's change everything. Yeah, it says that the no need to give the init, just you can directly give the EPSC to 4269. Okay, let's try by this way also. If we SC that is 4269, 4269, hit enter. Yes, and let's plot together and visualize the result. Okay, we can copy the before code, and I think it must have to work at this time, but we have to give rename the boundary to boundary project at this time, because the reprojection raster vector is boundary project. And I think aspect must be finite. Okay, because it only show the raw data, but it doesn't show any boundary data. And I think the problem is in boundary data, problem is in projection. Again, I hit explain error, and Gemini, I think it's a Gemini who is helping us, and it suggests us to change the aspect to none. I'm going to same, yeah, boundary project, inside the boundary we are going to aspect is equal to same, a none. Okay, none at this time, hit enter. It solved the problem, but it's still we did not get any boundary data here, because the boundary is in somewhere in the somewhere in my cursor, but it does not show. And one thing is, we mentioned the boundary data as the color red, and so we did not see any red color here in the figure. So I think in code, and it's boundary project, and again aspect must be finite, something like that. Aspect, okay, it suggests me to non aspect at this time, but still the same result. I'm not sure where I'm missing. Okay, and all things are same, but I don't know. Okay, let me figure out the problem. I think at this time, yeah, it suggests me to do the aspect none has been added to the boundary project function call, and we disable the automatic aspect, yeah, because I think we have a problem in the projection file. Yeah, we have to, yeah, let's reproject to get reproject the project the file. Yeah, it's in the 4269. It's the completely same, but okay. Let's change the way how we reproject. Yeah, it may the problem due to the when projection. Yeah. everything is okay. Let's keep the same parameter on the both of them, whether it's work fine or not. That's not. So expect must refine it and the query. Keep the exploit quick. Doesn't work at all. Okay, let me reproject the picture, or something we have to do. Define 23. Yeah. I'm sorry. It takes too much time to figure out the problem. It's the nature of the coding. Yeah, I think if I reproject the raster by the first method, I think it will work. Yeah, it is doing something. Yeah, it is doing something, and yeah, it's give us the error feature warning, but wow, yeah, it's work perfectly fine. It's the raw data and the boundary data here. So we make both of the data in the same coordinate system, and it works perfectly fine. This is the so we can start the geoprocessing, clipping and the buffering and intersection, union, merge, any of the geoprocessing. Yeah, you those intersection, union, dissolve, merge, and anything. We can perform any of the geospatial data analysis. Let's try with clipping. Okay, do you know the clipping? If we keep both, if we it's like chopping, right? There is the input file and and the one file that and one overlapping file, and if we run the clipping and those overlapping files, just chop the input file and give the file give only those file that is lies inside its boundary. So we can run the clip by clip road is equal to gdp.clip Madeira road boundary project. We are clipping the Madeira road by boundary data and clip road plot. Okay, let's plot the clip road. And Okay, figure we have okay, let's mention the figure size and the axis, PLT the subplot, and the figure size is 12,8. Yes, let's hit enter. Axis is equal to axis, we have to mention the axis. If we make the CMAP is equal to gray, and the PLT dot show, yeah, it first give the label to the latitude, give the labels, x label and the y label, and the row data and the title, and then we can, yeah, y label, title, and then hit shift enter. Yeah, you can see the school clip roads, and similar to this, let's try the buffering. Okay, let's buffer the road by 10 meter and visualize how it looks. Okay. Okay. And the buffering is done when we need some proximity values, right? If you need to know how many nursing colleges are lies inside the 5 meter, 10 meter, along with the 10 meter, near to the 10 meter of the road, then we can run the buffering and then clipping, then after clip to get the road. So we wrote the clip road by we run the buffer road by 10, and let's plot the buffer road, buffer road dot plot buffer road dot show. But I think there is some terrible mistakes, or we have to, and what is the problem here? Okay, it is due to the problem that I think we uh, keep the data in the geographic coordinate system, so it rather than buffering by the 10 meter, I think it buffer by the 20 meter, 10 degree, so that uh, the feature is not so good. So it buffer by each feature is lowered by 10 degrees. So we have to so how can we do this? We can do this by reprojecting to this raster to the projected coordinate system. Yeah, reproject raster into projected coordinate system. Okay, and this time again change to the give the values to okay, it's, I think it's a clip roads, and give the 32611. Yeah, and let's start the buffering again. Projected the plot, it's a clip road, and you can see in the axis, now you can see the projected values, right? Those are in the meter value. So buffer road, it's called buffer road reprojected. Yeah, we accept buffer road, that is they've already projected dot buffer by 10 meter. And okay, let's visualize, plot the road. Yeah, okay, this is the you can see, yeah, we can differentiate the plotted here. So let's try with by 30 meters. We definitely visualize the difference after, I think, after. Okay, yeah, you can see the 30-meter buffer road. And if we mention the CMAP value to the gray, yeah, okay, yeah, it's cool. And I think this is the, I have completed the course. You can also explore the more and more from the Geopandas library here. And yeah, you can go to the Geopandas tutorial, Geopandas, yes, and yeah, all things are here. I take some of the, almost all of the course from here, so to make you I'm making this video to make easy for you to follow, rather than if you prefer, then yeah, that's all. Okay, bye bye.